In this module, we're going to be using Stata to compute life tables. The dataset we're going to be using is called lifetable.dta, and this dataset was generated from one of the first life tables ever recorded, which dates back to the late 17th century. Now this dataset has 1,000 observations and only one variable, age, which represents the death times. Now the first question we might ask is, what is the mean lifespan and what is the median lifespan? And we can do this in Stata through the use of the summarize command. So we use the summarize command with the detail option, and we can see that the mean lifespan is 33.85 and the median lifespan is 33 years. Now another question we might ask ourselves, what does the histogram of the death times look like? Is it symmetric? Is it skewed? So to do that, in Stata, just go to Graphics, Histogram, Age, and click OK. Now we notice that this histogram is certainly not symmetric. There's a large proportion of death times close to 0, which represents the increased infant mortality during the late 17th century. After that, however, the histogram does appear to be roughly symmetric. Now we're going to use Stata to construct a life table. And this is very easily done through the ltable command. So type in the following command, ltable age. So now as you can see, Stata will give us a life table, but if you notice the intervals here, they're all of length 1, which isn't very useful. It's very hard to work with that. So what we're going to do is we're going to create different intervals. We want intervals of length 5. So how do we do this in Stata? We're going to use the interval option with ltable. So type in the following command. So what this interval option tells us is we want our intervals to start at 0, we want them to go to 85, and we want them to be in steps of 5. So these intervals now are 0 to 5, 5 to 10, so on and so on. They're of length 5, which is a lot easier to deal with. So now we have a couple of questions we want to ask about the life table. So the first question we want to ask is, what is the chance of surviving from birth until age 80? Now we can use Stata to do this. Stata will actually compute this value for us, but we can also compute it ourselves. So first off, we're going to compute it ourselves. So we started off with 1,000 people. We want to know how many people made it to age 80. So what we do is we look at this beginning total column, and that tells us how many people began that interval. So for example, 598 people began the interval 20 to 25. So what that means is that 598 people made it to at least age 20. So we're looking at age 80, so we see that 41 people made it to at least age 80. So that goes up top, and we can use our calculator to find out that that value is 0.14. So that is, the chance of surviving from birth until age 80 in this cohort is 4.1%. Now Stata will actually compute this probability for us if we look under the survival tab, the survival column, and what this gives us is the probability or the chance of surviving beyond that age interval. So for example, this 0.4450, that's the chance of surviving beyond age 40. So for our case, we want to look at this number right here, 0.041, and that's the chance of surviving beyond age 80. So that's a 4.1% chance, just as we calculated. Now the next question we want to ask is, what is the proportion of individuals alive on their 50th birthday who die before their 55th birthday? So the first thing we have to do is find out how many people were alive on their 50th birthday. So what we do is, again, we look at this beginning total column, we find this 50 here, and we see that 346 people made it to at least age 50. So out of 346, how many people died? So we can look at this death column, and we can see that 54 people died in this interval. So we have 54 out of 346. So that leaves us with 0.156. So that is the proportion of individuals alive on their 50th birthday who die before their 55th birthday. Now the next question we want to ask is, what is the chance that a 25-year-old will survive 10 years? So first off, we have to find out how many people were alive at age 25 or longer. So again, we look at this row here. We see that 567 people made it to at least age 25. So out of that 567 people, how many survived 10 years? So what we can do, so 10 years, 25 plus 10 is 35. We see that 490 made it to that interval. So 490 people made it to age 35 or more. So now we can you can use a calculator to do the math, and that equals 0.86. So there's an 86% chance that a 25-year-old will survive 10 years. Now the final question we want to ask is, was the chance that a 10-year-old will survive to age 60? So again, in Stata, we have to find how many people were alive at age 10 who made it to their 10th birthday. We can see that 661 people made it to at least their 10th birthday. We want to know how many people are still alive by age 60. So that's 200, and we can see that's 242 people made it to their 60th birthday or longer. So we can do that math, and we get 0.366. So there's a 36.6% chance that a 10-year-old will survive to age 60. Compare that to the US in 1992. That chance was 87%. So in 1992 in the United States, there was an 87% chance that a 10-year-old will survive to age 60. And that's the end of the life table module.